Good morning, everyone. Welcome to another episode of Xah Talk Show. Today is 2021, April 18th, and today we are going to do emacs lisp coding, live coding, and today we are going to explore the fuzzy matching in emacs lisp. Fuzzy matching is like, it's very useful. You'll see what it means. So it's going to be mostly about Emacs Lisp coding, and I'm going to explain as we go, exploring fuzzy matching. There are different kinds. I'm going to explain. Okay, so let's begin. And by the way, today I'm using my newly bought microphone. Okay, this is, so now I got the dedicated microphone. So now newly bought microphone. I got a dedicated microphone. So is my voice good? Okay, so let me show you the microphone. Actually, let's take a minute. Just go to let me show you the microphone. Okay, Xah keyboard. So you go to my keyboard blog, search for Xah keyboard blog, and you can see miscellaneous, and I've done some research on microphones. So you can see, shopping choices, and I end up buying this one, pretty cheap, $35 or something, and looks like it's working fantastic, fine. Dedicated microphone is much better than headset. My headset has hum issue, like scream, fantastic. Good morning, Bart. You are not sleeping yet, and good morning, Zitron Crazy. Okay, actually, so we're gonna focus on emacs lisp today, just emacs lisp. So let me begin. Okay. Meanwhile, let me turn this so you can watch my keyboard instead. Since emacs coding, it would be fun to just watch at my keyboard. I type. Okay, so let's see. Okay. Hold on a sec. Okay, so yeah, emacs lisp coding. So let's begin. Okay. So I'm going to start. Okay. So on the left window, the pink window is all the command calls. You can see whenever I press a key in Emacs, every keystroke ultimately becomes a command call. So if I move cursor by words, you can see it's actually calling for a word. And you can also see the key I'm pressing to do that. I'm using Xah keys, and I'm using a Vorak keyboard. Okay. So now let's begin. So first, so you can, if you are on YouTube, you can see the topic list. Okay, I have the topic list prepared here. So let me show you what we are doing. Okay, so we are going to write a. Let me demonstrate. Okay, so let's see, emacs lisp. So start an empty buffer and define a function, and let's explain what does this function do. Okay. The function will be select, let's name it select choices. Okay, select choices, and select from a list of choices, predefined choices, using, and then insert them into buffer. Okay, that's what this function does. And let's put today's date. Okay, that's what this does. So let's begin. So first of all, what kind of choices do we want? Okay, now when you write academic paper, there's lots of repetitive kind of sentence structures. Okay, let me show you an example. Okay, let's just show you a simple example. Okay, so here is a list of sentences. If you are in academia and you are writing a lot of thesis or report or publications, there is a particular style of writing which is impersonal. that is the style of academic writing. And if you search online, for academic phrases, you'll find tons of those kind of database. So here's an example. This field closely follows the paradigm of something something, widely considered to be a good way to something something. This has been widely adopted in the field of something something. This is more widely used at the time of something something. So those are type of the academic style of writing. So when if you are a professor, you may find what we are doing today useful. Okay, so let me show you. So these are the choices. First of all, I want to make each line, I want to quote each line, make them into a emacs lisp list. Okay, so let me show you what I do. Okay, I press 3 keys. So actually, let's undo. Let me show you. Okay, copy, paste, do that. Okay, that command you can see is called Xah quote lines. Okay, and now we just say list. Actually, okay, copy that, just paste here. So we have a list here. Let's call them phrases. Okay, let's put a variable here. So the variable is phrases, and the value will be predefined list of phrases. Predefined. Okay, so these are the choices we want. Let user choose. Once user choose one, it will be inserted to the buffer. Okay, so how do you write that? Let me show you. Okay, let's say let's do some quickly. So let's do something quickly. Messages. Okay, and we are going to say phrases. We're gonna print phrases. Car phrases. Car just means the first item. Okay, so that is the function. That's it. So now we evaluate the function, then call it meta_x, select choices. By the way, when you do meta_x, you can see in my mini buffer. Sorry, excuse me. So you can see in my mini buffer, I'm using the one of the meta_x. What is it called? Smax. But anyway, so you can see there is it lets you pick some choices. For example, if I type Xah, then it shows all the commands starting with Xah. So that's what this is similar. That's what we are doing today. We are trying to implement something similar. Okay, so let's call meta_x. Let's put a cursor at the bottom. Meta_x, then type select choices. Okay, enter. Symbols value as variable is void. Phrases. Okay, there's an error. Why is the error? Oh, yeah, yeah, because you see, this part needs to be inside the let. Okay, so put it here. Yeah. Yeah, what? So why is it all these? Oh yeah, so actually, so this nested parenthesis, this is an indication of the problem of nested parenthesis syntax. Some minor issues. I mean the disadvantage of nested parenthesis syntax. So sometimes you got confused which one is inside which. Yeah, okay, now this is good. Okay, evaluate the buffer, put a cursor at the bottom, call it, select choices, enter. You can see at the bottom, you see it actually printed the first line. This field closely follows something. Okay, if you have comment and questions, just post it. Okay. Zitron crazy. Wanna see my pretty face? Do you suggest I use Doom Emacs coming from Vim? Okay, I'm not gonna talk about that because different, basically the answer is different people have different choice. It depends on the person. So anyway, let me continue with this. Okay, so now we are going to write modify the code so that it lets the user pick one of the choices. Actually, I need to go faster because, yeah, we have a lot to do. Okay, so let me show you what to do. Okay, I do read. This is how you. Okay, I forgot what's the name. Okay, so what you do is you go to Xah emacs lisp. Okay, so you go to Xah emacs lisp website, practical emacs lisp. Then you go down. There is a section about basics functions, but text editing, buffer, string functions, buffer, read write file, writing command, get buffer string, work with lines, get user input. Okay, click on that. Prompt for file name, prompt for directory, prompt for string. This is what we want. Okay, read string. Okay, that's the command we want. Okay, so back to here. So actually in Emacs you can say read string, but actually there's a better version that is I do read string. So it's I do read directory name, I do read buffer, I do read file name, I do read buffer. What the? Wait, there should be a I do read string. Okay, there's no such function. Oh, actually, I have an example of I do right here. So, I do completing read. Yeah. Okay, so here is the function we want. Copy it back to Emacs buffer. I do completing read. That's right. So here, let's see the documentation, describe function. So here is the full syntax, copy and paste it here. Okay, and let's see. Now we don't need the message part. Okay, delete that. I mean, comment it out. I do. Okay, complete read. Okay, let's do this. Okay, prompt will be make a choice. Okay, then the choices will be phrases. Okay, then optional, we don't care about optional. Okay, so that's it. Okay, then you need to set the let's do a variable user choice. Okay, user choice is a variable here, and now we're gonna set user choice, and that's gonna be this line. Okay, user choice, that pretty. Okay, so now insert user choice. Okay, that's it. Let's run it. Run our code. Move the cursor to the bottom. Call it. Select choices. Enter. So now watch. Okay, so you see Emacs now prompt us with a bunch of choices. Now I'm going to start to type. As I type, it will start to narrow down the choices. And this is the heart of fuzzy matching, because fuzzy matching is a very useful feature. It lets you, it saves a lot of typing, because of all the choices. For example, Emacs commands, you do not remember how exactly the full name of the command, but you do remember some words or part of the words in the command name. So you can just type that, and it'll be able to show that as a selection, and you can pick it. So right now we have the similar situation. So let's say we want the third, we want the line that says widely adopted. Okay, so I type, watch what I type. Okay, WID, You see? Let me try it again. Magnify, okay? Let's do this. W, okay, as soon as you type W, then those sentences doesn't contain it will be eliminated. So you see, W, okay, I, D. Okay, then let's type G. Okay, now G is a word here. Let's type G. Okay, now that's the only selection. Now enter. That's what we want. So you can see it inserted that phrase. Okay. So we have completed, essentially, this is the first part of today's tutorial. This is how you use fuzzy matching, how you write a command to have fuzzy matching feature to let users select a predefined list of things, okay? This list of things can be anything. It can be sentences, it can be a list of command names, and it can be whatever, it's a part of user interface. Now, okay, questions? Now, now for our application, we are going to have actually potentially 1,000 phrases. So, and each phrase may be a long sentence. So that means our command, the way we implement it, needs to be fast. You cannot, if you have to, every time user calls the command, it waits for, 1 second or 2 seconds to do it, then that's no good. Okay, we need it to be fast. Thousands of choices. Okay, so that's how you write it. You can in fact copy this code, paste in your emacs init file, and it'll work for you already. Okay, now let me show you, like if you just search for, okay, let me show you, okay, academic phrases, okay. You see, there's a lot of people searching for it because in academia, professors, academia, they want, they write a lot of papers and it's very tedious to type all these. Let's see. So, I've seen this before, so let's go to some of the choices, okay? Let me show you some of the examples. So here is a page that lists academic phrases, sentences, and vocabulary. So you can see how many of them there are. They are grouped by category. Okay, so lots of, and this is just one of the page. There are like 100 more. So that's the point. That's what I'm saying. You potentially have 100 choices. Okay, and by the way, these multiple choice user interface is truly extremely useful. I also use it for a brief because I have hundreds of briefs, but some of them I don't use very often, so I forgot what exactly is a brief. So I can, so I have a command that lets me select on the fly which brief I want. So very useful, okay? Now, the next thing, so this is what we are doing today. Now, the thing we want to talk about is about fuzzy matching, because if you have thousands of choices, there are many types of fuzzy matching. Now, in our case, for example, let's try to insert this line again, okay? This has been widely adopted in the field of, so let's try it again, okay? So I'm gonna show you. So select choices, let's magnify, okay? So watch what I type, okay? So I'm going to type the first character of each word, okay? This has been widely adopted in the, you see? So if you type the first character of each word, that will work, okay? But if you type the last character of each word, it will also work. Let's try it again. Let's say, so it's gonna be SSNYDN. You see, that also works. So So the fuzzy matching used here, let me try it again, okay? So let's see. Let's try the word has, okay? You see, there are two sentences, I mean, two of the choices that contains the word has, okay? Let's try it again. Coed, select choices, yes, and HAS, okay? So we got our two sentences. Now let's add one more sentence. Let's try add one more sentence. H something, let's say heart, the heart follows the brain of, okay? Let's make a silly sentence. This heart follows the brain of, okay? Now, notice in this sentence, there's no such word, has. Has is not in this sentence, okay? Now, we evaluate the buffer, call out command again. Now, I'm going to type has, H-A-S. Okay, it's not showing up. It's unexpected. Let's try again. HAS. Okay, this is not expected because what I'm trying to say is that fuzzy matching, because I was trying to get it to show this line. Why? Because this line contains H and A and S. Okay, let's try it again. This time let's type HAT. Okay, so if you type HAT, it works because it matches part of the word heart. So now let's try THA. Okay, let's see what happens. THA. Try it again. Try it again. Select choices. THA. Yeah, so that's my point. THA will show up the sentence because T is in the first word, then H. Let's try again. THS. So right now we are trying to, basically what we are doing is that we are trying to find out exactly what kind of fuzzy matching, I mean how exactly our text input, exactly what's the criteria, how exactly it uses our input to match the selections. So let's say HE. Let's say HEO. Okay, that works because HEO is the second character of each word. Okay, but why is HAS does not work? HAS. Let's try again, okay? HA. Okay. Okay, I think I kind of see it. HA excludes the first choice because the character you type, I don't understand why does not it includes the first choice. Try it again. SOL. Okay, that works. HHAS. Okay, that works. Okay, so if you have HHAS, that works. But HAS does not work. So what about TST, right? TST, that should also turn up the first sentence. TST, it does. So why is it HAS does not work? HAS, well, because between H and A there's an E. Is that how? So if we try TIH, would that work? TIH, it should not. TIH, it does. So why is it HAS does not turn up the first? I don't understand. But I think we're gonna move on. Okay. So now let's see the comments. Okay, big comments. Okay, you guys are chatting random. Okay, so now if you have questions for me, put my name to it. Okay. So now I do not understand exactly how the I do completing read is the criteria it uses. So we can look at it to see how it is to find the answer. Okay, so describe function, then we can see the documentation, and we can go to the source code. Okay, go to the source code, and we can see how it is implemented. So here it is. I do read internal. This is the heart of the fuzzy matching part. So let's go to I do read internal. Okay, actually there is some I do read internal. Let's look into it. Okay, search next. Make the prompt for I do read internal. Oh, okay, so they actually have a documentation for programmers explaining how it works. Here is very briefly how I do find file works. And here is the implementation. Okay. Now, so now this is actually the heart of I do mod. So you see, oh my god, it's okay, it's few hundred lines. Let's see how many what is this? 345 lines. I do read internal. This is the heart of I do mod. 345 lines. So, but exactly how it does the match. So let's search for rejects. Oh, it doesn't even use regular expression. Amazing. I mean, so this is the first time I'm looking into the I do internal. So it does not even use regular expression, because I thought it's creating a regular expression on the fly. So, okay, let's quickly find out exactly how it is done. So, I mean, I'm interested. I want to know. Let me just look, okay? So if require match is nil, an existing file must be selected. Okay, so require match. let's say, let's search for scan, okay? These matching lines, scan. Yeah, I cannot see. Okay, it's list matching lines, scan. Wow, so actually I'm surprised. It's implementing its own completion, basically. Let's save it. I'm gonna study this offline. Okay, so far so good, guys. How many people are watching? 5. So let's see. So okay, so that's about I do. Now let's look at Helm. Okay, so let's get start to do something interesting. So now we explain. Let's close. Let's go back to our talk show page. Now we have explained what we are doing. We wrote a function using I do. We explained the possible choices can be a few thousands, and we demonstrated what fuzzy matching is. Now the point here is that there are different types of fuzzy matching. That's the main topic of today. So as we have seen, the fuzzy matching in IDoMod, essentially when you type something, it takes them as it takes them as a sequence of characters, and if that sequence occurs in one of the choices, then it'll show. It does not consider space or so it's basically character-based sequence match, essentially. But so what is the problem? But there are different type of fuzzy matching. For example, in the IDoMod, the word order, the character sequence order we user types is very critical, because if you type, for example, you type the same character but reverse, it won't work. For example, the first line, this heart follows the brain up, okay? But if you type follows, then followed by heart, it won't work, okay? Let me show. So order is important. So I do fuzzy matching. Let's do a demo first. Coed, select choices. So I'm going to type follows heart, okay? FOLLOWSHEART. No match, because there is no sentence in the choices that contains this exact ordered sequence of characters. So I do fuzzy matching is a character-based fuzzy matching, and order matters, okay? Now let's explore other types of fuzzy matching. In particular, let's look at Helm's emacs. I know it does fuzzy matching, but word-based, and order does not matter. For example, if you have a emacs, sometimes a emacs command, you forgot, some words in it, but you forgot what's the order. For example, list matching lines or match lines list, something like that. You don't remember the order. So sometimes you want a fuzzy matching that ignores the order, but consider each word. So for example, in our case, sometimes you just want every, you want to show a list of phrases that contains the word observed, for example, because you do remember that that is a sentence you want. So you start to type observed. And if you use I do, then it may show many other sentences that actually do not contain the word observed, because it's character based. The whole sentence contains the characters O, B, S, E, R, V, E, D, but there's no single word that contains match observed. So such sentence we also turn up. You don't want that. You want a word-based fuzzy matching. So let's look into let's install Helm. Okay, let's look. So let's go to my .emacs. Let's see if I have Helm installed. Okay, Melpa. Search for Helm. So actually, I have Helm installed. Okay. So let me show you what we are doing. So let's look at Helm's implementation of emacs. Okay, that's what we are doing. So first of all, turn on Helm mod. Okay, so let's see Helm. Oh, actually, we don't need to turn on Helm mod. We can just directly call Helm emacs. Okay, try it. Yes. Okay, so there we have it. So now we type select choices. Select. Oh, you see. So Helm's meta-X is, its fuzzy matching is very different from I do. For example, the command we have written, let me show you, okay? First of all, exit. So the command we've written is called select choices. And we can call it by, okay, for example, we try Helm meta-X and we type choices, okay, and space select. You see? It shows up because it ignores order. And also, the space character serves as a separator. But in iDo's fuzzy matching, space character is basically ignored. Okay, I believe so. So Helm's fuzzy matching is word-based, and space serves as a separator, and the word order does not matter. Okay, so this is what we want. So I'm going to start to look into how this is implemented. Okay, Helm MX. Okay, so we write it down. This is the command. Okay, let's describe function on it. Now Helm MX is a automated interactive compile list function in Helm commands. Okay, let's see. Okay, let's just go to the source code. Open. There we have it. Magnify. Okay, so let's see how this works. Pre-configured Helm for Emacs command. This is Helm replacement of regular meta-X. Unlike regular meta-X, Emacs vanilla execute extended command. The prefix args, if needed, can be passed after starting Helm X. Okay. When a prefix argument is passed before starting Helm meta-X, the first CU while in Helm MX session will disable it. Interesting. A bit confusing. If you don't know what, if you I'm not, the prefix arg. If you understand that, I'm not going to explain because we got other things to do. So you can get help on each command by persistent action. Okay, so anyway, let's see how it is implemented. Okay, so wait, what? Okay, so first of all, interactive. Okay. So okay, so the arg here, that's basically that's the prefix arg. Okay, that's the argument for this command. Basically, this part means when user calls this function interactively, how does the function's argument, this one, gets a value, and that is defined. I mean, that's specified by this code interactive. So we can kind of ignore that. Because it's about current prefix arg. If you don't know what that is, just search for it. I have an article on that, but we don't need to care about that for now. So here is the main body of Helm. Okay, so if defining keyboard macro or executing keyboard macro, then do nothing. Basically, just call. This means just call the standard emacs meta x, right? Yeah, because when you're defining a keyboard macro, the fancy interface usually interferes with your recording. So if you are actually defining a keyboard, if you are in the middle of doing that, just call the regular meta x. Otherwise, here's the heart of Helm meta x. So it says Helm meta x read extended command up array. So up array basically is a vector, is a list. It's actually a vector. It's a list of all emacs commands. So this thing up array is actually contains a few thousand items. Okay, more than 1,000 for sure, because I've seen it before. So anyway, so this is the heart of the Helm meta x read. Okay, let's search for that. Okay, and it is defined here. Let's see how big is this. Okay, not too big. Now narrow to region, narrow to the function. So it's 60 lines. Let's see how it's implemented. Okay, here I see the word flex. Flex matching is another fuzzy matching method. Okay, let's read the documentation. Read or execute. Okay, so here's the command name, collection, predicate, history. Okay, read or execute action on command name in collection or history. Okay, when this command is used, okay, when something style is used, several actions as Helm type command are used and executed from here. Otherwise, this function returns the command as a symbol. Okay, Helm completion is not provided when executing or defining keyboard macros. Okay, arg collection should be an ob array, but can be any object suitable for try completion. Okay, yeah. So how is it done? How is the fuzzy matching done? That's the thing we are interested. Am I doing good? Does Vio get okay? You guys are chatting random. Do we actually have emacs people here? Current viewers 5, 6. Okay. Anyway, so let's back to Helm. Let's see how it implements the flex matching. So let's just search for flex. Okay. Okay, that only occurs one time. How long have I been talking? 46 minutes. Yeah. Okay, let's see how this works. It seems somewhat complex because, actually, we are not, I don't think we are looking at the heart of the fuzzy matching. It's not here. It's probably some other function that actually does that. How do I know? Because when you call Helm meta x, it has a different user interface from the GNU Emacs. You see, it does not pop up a list of options in the mini buffer. Instead, the mini buffer remains, like the mini buffer, but the list of choices is in a separate buffer. And also the list of choices has fancy fontification in Emacs terminology, fancy color and font. So as you type, for example, as I type, let's say copy, then it started to, it changes the choices buffer, and very elaborate. You can see syntax coloring. You can see command history section. It actually has several sections: command history section, Emacs command section. Okay, yeah, okay, 2 sections so far. And all the words copy is highlighted. Let's say COP. Yeah, so what if I type 2? Okay, then you have command history section, Emacs command section. Okay. Okay, what if I type GG? Okay, GG. Yeah, so one thing I noticed, one thing you notice here is that the Helm's fuzzy matching system, whatever you type, the characters you type must be within a word and continuously. So that means when you type GG, then this sequence, then, one of the choices must contain exactly GG with nothing in between. Otherwise, it doesn't, count. It doesn't match. So that's why I say Helm's fuzzy matching is kind of like, it's like substring of a word based system, and the order of word does not matter. Okay, so anyway, Helm has this special interface. Now we are trying to find out exactly where's the code that does the fuzzy matching. So it's a bit complex because since it has to generate this fancy interface, so there must be a part that does the interface and another part of the code that does the fuzzy matching. Okay, let's see the code. Let's start to read the code. This is where I'm gonna be quiet because I need to read the code. Okay, Helm outline display. Okay, mini buffer completion confirm predicate. So these are a bunch of local variables. Metadata. What is it? Associate list flex completion style list. If it's not true, then metadata equals to that. Now what is metadata? Display sort function. Okay, so basically, okay, candidate, sort candidate. Okay, lots of things. So metadata, and what is the next source? Okay, so then you have emacs command history. Now this sources, okay, sources, this is a combination of all the possible choices, probably. Okay, and the Lisp code here is a bit advanced because you can see they are using this backtick. Backtick basically means evaluate only part of a list, not every element in a list. Okay, so anyway, sources is creating probably creating a list of all the input sources selections. So now you have prompt Helm metax prefix argument, okay, then and something. Okay, prompt is not too important. Basically it's a string to prompt user, okay, metax. Now Helm x timer, so they also have a timer. Fix bug, add Helm move selection after hook. Okay, I don't know what that is. I'm not sure what the timer does. Then add hook, Helm move selection after hook. Helm move selection after hook. Then you add the function Helm metax move selection after hook. Okay, I'm not sure exactly what that means. Then add hook Helm before action hook. Okay, something. Then okay, now here is probably the main part of the code. Okay, let's see. When and sources and reverse history. When that is true, set sources, reverse sources. Okay, that doesn't matter. It just reverses the order of the, for example, command history, so that the more recent becomes on top, something like that. Then okay, so here is the heart. Oh my god, so the heart of this command is very short. So now I understand, I can see that basically the entire thousands of lines of Helm is essentially based on this single command, Helm read extended command. Yeah, because that's what Helm does. Helm is a emacs package that basically allows you to call one single command, and that can be a file name, can be a search string, can be metax, something like that. Helm, one single command, and you can just type and just match. You'll narrow down among file names, or open file history, or command name, or command name history, things like that. So you don't have to think about, am I going to opening a file, or am I going to call a emacs command, or you just start to type. You just call one single command and start to type. So that's essentially the paradigm of the Helm package workflow, something like that. Okay, more or less. So now I realized, so this command we are looking, I think, okay, so far, so I think it's actually kind of the heart of Helm. And okay, so then this command is actually calling, here is very advanced emacs Lisp code. So here's the heart of this command, the code. Unwind protect. Essentially what that does is something like, in case there's an error, what to do. It's rather, it's one of the deep emacs Lisp code. Usually you don't call this. Okay, so unwind protect. So program set current prefix arg neo then call Helm. Okay. Here is the, here's the part, here's the heart of the Helm. So it's simply, you see, it's simply called a Helm command. So Helm command is the master of the entire Helm package, is this function Helm. So it says sources, okay, then prompt, okay, then buffer, okay, then history, okay, so now, okay, now we understand. We want to look into the source code of this function Helm, okay. So expand narrow to region, and let's describe function on Helm, okay. So there it is, the documentation for the Helm function. So Helm is an auto-loaded compile list function, Helm in Helm EL. Helm key sources input. Okay, everything is optional. So actually, we can actually compile this function. So it's not a command. You cannot actually call it directly. So let's try to call it. Helm. Yeah, there's no such function by itself. This is a command. This is the engine of the Helm package. So essentially, it's probably the case that every command you call in Helm will eventually call this command. Okay, so it says the main function to execute Helm sources. Okay, so this is, so we need to look into this function. This is the function we are looking for. So let's blah 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 blah. Let's jump to the source code directly. Okay, enter. So now let's see how many lines are there. Wow. Okay, so let's see, narrow to define. Okay, 160 lines, not many, and most of it is actually comment. Lots of comments. So it's actually 50 lines of code. So that means the fuzzy matching implementation is actually in another command, even deeper. Oh my God. We've been talking. So comments. Hey Xah, long time no see. Anime Ziad. Okay, I forgot. Sorry. So anime, join Discord, so we can, chat. Okay, so how long have I been talking today? We've been going on for 1 hour now. And right now we are looking at the source code of Helm to find out how it implements its fuzzy matching completion. And now we are looking at this function. This function is simply named Helm, and we believe the fuzzy matching engine is in one of the function this function calls. So we haven't found it yet. So we need to read up on what this function. Okay, let's read up. Okay, let bunch of local variables. Fn is a function, I think. Blah blah blah. Helm nest. Keyword p. Okay, let is define a function. I mean a local variable fn. And fn, what is fn? Condition. If Helm alive true or something, then the function should be Helm nest. Oh, okay, got it. Now okay, we are closer. Okay, so now we are closer to finding the implementation of the fuzzy matching used in Helm now. So first of all, it defines a local variable fn, which is going to be a function. You see, so the possible choices of the function is Helm nest, or again just Helm itself, or the Helm internal. So it looks like Helm internal is the function we want. So we are diving another layer deeper into Helm. Okay, so that is Fn. Okay, so that is Fn. Now let's magnify. Okay, now let's see what the code does. So if Helm is alive, something something, then Helm is alive internal variable. Okay, something something. Helm is alive. If Helm is alive, okay, Helm buffer, okay, yeah, that we don't care. Okay, so if Helm is not alive, then okay, so Helm alive means you are already calling Helm. For example, I'm calling Helm, so you see right now I'm in a state of Helm alive. That's what it means. Yeah, so that's essentially what this part means. So if Helm is, you are already in Helm, then error trying to run Helm within a running Helm session. Yeah, that's so if Helm is not alive, then what we do? So we do here. So if keyword car plist. Now I don't know what a plist is, a property list. Okay, keyword. So if it's a keyword, pass plist and move not regular Helm argument is okay. Whatever. So if it's a keyword, then you do that. Otherwise, you just do that. Okay. So here. So Fn equals to Helm internal. Yeah. So here Helm internal. So we advanced. We made progress. Helm internal is now the function we want to look for. Helm internal should contain the implementation of how Helm implements the first imagine. Okay, so let's describe function Helm internal. Okay, let's look at the inline doc. Okay, Helm internal something something something. Okay, again similar syntax arguments, internal Helm function called by Helm. Okay, yeah. So let's jump to source code. Let's jump to source code. There it is, Helm internal. Now narrow to define. Let's see how many lines is it. Okay, again 100 lines, not too many. So it's, so apparently the Helm's coding style is very modularized. It tries to, for each function it just have 100 lines instead of a huge number of lines. Okay, Helm internal. Okay, the internal Helm function called by Helm, right? So let's look at the code structure. What does it do? Now again, our goal is to find how Helm implements first imagine. Okay, so let's see. I don't know what, I'm just looking. Advices, Helm nested. Okay, whatever. Let's just scan. Let's scan and see if there's some words about pattern or regular expression or first imagine. Okay, unwind, protect. Okay, oh my god, this is okay, there's a lot to look into. Helm read from mini buffer, prompt input. Okay, so Helm read from mini buffer. So this is where Helm, when you type this function, lets you type something. That's how Helm gets input. So we are several layers down and we still haven't seen it yet. So Helm read from mini buffer. So Helm log advice remove, bound advice remove. So actually, so Helm is actually fairly complicated package. Helm allow mouse. Okay, so now it looks like Helm read from mini buffer is the function we want to look into. Yeah, let's go up. Let's see what else. Okay, yeah, I'm guessing this is the function we want to look into. So okay, let's describe function on that. Let's see what it says. Helm read mini buffer is a compile list function. Okay, read pattern with prompt, and initial input. Yeah. Okay, but it doesn't return anything. You see, does it return to something? I don't think it returns anything. So anyway, let's go to the source code. Okay, go to the source code. Here is the code. Oh, okay. So let's see how many lines are there. Okay. Narrow to define. Again, 100 lines. Each function is just 100 lines, no more. Okay, we are diving 3 levels down by now. Okay, Helm read from mini buffer. Yeah, again, similar arguments. So we are trying to find the how it implements fuzzy matching. Okay, now finally, Helm read from mini buffer, right? Prompt input, okay. With Helm buffer, oh my god, with Helm buffer, you know, it defines its own with Helm buffer. Okay, then, okay, I'm actually getting tired. So any comments? No comments. What's a font? That's a standard font. That's a Consola. That's a Windows standard font. Okay, for monospace for code. With Helm buffer. Okay, so that's basically the whole thing. Then if statement, Helm resume p get current source. Okay, make mark current line, update pre-select. Okay, so let, you know, again, we are looking at Helm's formatting style, you know, Helm's source code formatting style. Now this deviates from the GNU Emacs style, because, for example, I can show you in GNU Emacs style. Okay, for example, if you look at you look at this block. Now I'm going to restyle it. You'll see this. You see this sequence of space will be good. So let me try. Okay, do it. Oh, actually, wait. Anyway, never mind. Never mind. Back to the let source process p. Okay, Helm log timer neo Helm log. Then when source Helm resume Helm display mod line. Okay, so pattern. Now we're starting to see pattern here. Helm pattern. Reset Helm pattern and update. Oh my god, this is Helm pattern, Helm input, Helm pattern. Okay, so there is a timer. Now I'm not sure what is timer doing here exactly, because I've seen timer mentioned several times. Okay, I don't know. I need to go offline and study this, because right now I'm probably getting pretty boring for you guys. Yeah. Am I still like alive? Yes, I'm still talking. Yeah, let's hold on a second. Let's put my face. So yeah, I think we're gonna stop now. It's taking a long time. Should we stop? We are trying to find how fuzzy matching is done in Helm, and we dived into several levels of nested, functions, calling functions, tracing, tracking the functions, and still I'm not seeing it, because really, because that's the heart of the Helm engine, I suppose. So I still haven't seen the actual code for the fuzzy matching, but we are getting close. Mini buffer we set up, so read from mini buffer, so it's actually calling, but it's actually calling this emacs lisp, GNU emacs lisp command to read from mini buffer. So what about input? There's an argument of input here. That's the user input. So can we find it? So this argument is actually not used anywhere, in the code. Okay, so the comment says enter now mini buffer and wait for input. Okay, so here, wait, what? So actually there's some comments here, maybe they are helpful. Reset Helm pattern and update. Display if no result found with precedent value of the Helm pattern. Okay, Helm pattern is probably what we want to look into. Okay, so Helm input, and what about the input? And okay, over here it says enter now mini buffer and wait for input. So tab, okay, so so from what I see now, Helm is pretty, Helm's source code is fairly advanced. It's not just a wrapper of emacs lisp or something. It's especially when you see this kind of thing, unwind, protect. Usually you don't call that. When you call that, that means your code is doing complex things. You want a way to, if there's some error, That's what unwind protect does. Normally you wouldn't call this. So unwind protect is in Emacs version 19. Introduced or before? Yeah, I think it's way before. Because unwind protect, unwind protect, here's a bit. Here's a bit. Unwind protect is actually, for my study of exceptions. In programming, there's let me just random talk for now a little bit. In programming, there's a concept of exceptions. And the meaning of exceptions is very different in different languages. So you can go to Wikipedia. There's an article on that, exceptions. For example, Java. Especially in OOP languages, it's very common to see exceptions. Meaning, basically, it's a object-oriented method of errors. Of tracking errors. Error handling. Error handling is a very complex issue. There are so many different approaches. But anyway, in OOP languages, today's understanding of exceptions is basically from OOP languages, basically Java. You can say Java's model, or it's also in JavaScript and also Python. Exceptions, which is essentially basically built-in go-tos. It's like mysterious go-tos. So if you search for Xah exceptions or history of exceptions, Xah history of exceptions, you can find it. Let me show you. Okay, let me do. Okay, so here's an article, Why I Hate Exceptions. And I have a quote from the Golang. Why does Go not have exceptions? And I did some research on the history of exceptions. So exceptions is actually, different languages, they are completely different. Even your language has exceptions, my language has exceptions, but they are like different things completely. So it turns out from my study, the first exceptions came from Lisp. Okay, Lisp language, and that exception is entirely different from Java or Python or JavaScript. It's throw and catch is it's also called non-local exit. So anyway, I vaguely recall unwind protect is one of the earliest error handling approach. Okay, so in a sense, Lisp, it is indeed actually, Lisp is the father of the error handling concept, exceptions. Okay, but however, Lisp, the unwind protect and throw and catch has nothing, absolutely nothing to do with Java or Python or JavaScript. They are exceptions. So anyway, that's a digression about unwind protect. Okay, that's the error handling thing. So back to the Helm, I don't know. So I haven't found what we're looking for. We are looking for how Helm, the engine of fuzzy matching used in Helm. So it's fairly complex. Okay, Helm is it's a non-trivial package. Okay, so we haven't found it, but however, we have some. What we achieved is some sense of how Helm is implemented. The Helm structure. So we can see, for example, we have Helm read from mini buffer, and the function that calls it is Helm internal, and the function that calls that is Helm. Okay, and the function that calls that is Helm metax. Yeah, Helm mx, right? So we have a list of hierarchy of functions. Okay, let's write them down. Okay, and that's it for today. So if let's see if I can remember. Helm meta x calls Helm calls Helm read from mini buffer, I think. Let's see. Yeah, okay, so oops, Helm internal, okay. So we have, this is what we have, okay. Yeah, so this is a sequence call stack, okay. Helm mx calls Helm, Helm calls Helm internal, and Helm internal calls Helm read from mini buffer. And they're small, but we are going to stop. So what we can do is, we want to implement our function, original function. We can actually make a different version by just calling Helm internal. I think that will work. Okay, let's try. Helm internal is a function we can call. I think so. Okay. So if we call Helm internal, let's call Helm read from mini buffer. Okay, let's see. So here's a code, Helm read from mini buffer. Yeah, we can, let's try to call it, okay? So we modify our code. Now, so here, instead of using, instead of using I do complete read, we use Helm, okay? Let's see, we use Helm complete read. Wait, okay. Let's see. Helm read from mini buffer. Let's see what happens. Okay, I'm not sure it will work. Let's see the prompt input. Okay, so let's try that. Okay, so select choices. Okay, so evaluate the function. Okay, then move to the bottom, call it, select choices, enter, wrong number of arguments. Okay, yeah, okay, it needs 7 arguments, and we only give it 2. Okay, so let's, instead of Helm read from mini buffer, let's try Helm internal. Okay, let's see. Okay, evaluate the code, call it, select choices. Okay, initial input should be a string or nil. Okay, so now let's try again. Now let's just try Helm. Evaluate the function, call, select choices. Initial input should be a string or nil. Okay. Yeah, so we cannot call it. We need to. Okay, that's it for today. We close down in minutes. Okay, thank you. Okay, Bot and Ztron Crazy. Good night, guys. Bye, guys.